Meet Dr. Jeffrey K. Leiker, a professor of industrial and operations engineering at the University of Michigan. Dr. Leiker also recently wrote a book, Developing Lean Leaders at All Levels. This book is an adaptation of the popular online course coached by Dr. Leiker, The Toyota Way to Lean Leadership. Learn from an expert and learn how to develop lean leaders at all levels to benefit your company. If you want to find out more, there is an online course of the book located at toyotawaytoleanleadership.com.
Thanks, George. As George mentioned, I'll be talking about standards, standard work, and visual management. All of us in the lean community hear about the importance of standards all the time and how critical it is in the Toyota production system. I'll talk a bit about why that is and what we do once we have defined a standard. What I'd like to cover are three learning objectives. First of all, why is it that standards are so important to continuous improvement? Second, how does this relate to visual management, which is another key part of lean? And then third, what do we want to do when we have a standard, when we have visual management, when we see something is out of standard? And one approach is to try to conform to the standard, and another approach is to strive toward some goal, towards some objective. I'm going to make that distinction, which I believe is important and leads to different behaviors. Henry Ford is often quoted about standardization as calling it the necessary foundation on which tomorrow's improvement will be based. And he said if you think of standardization as the best you know today, but which is to be improved tomorrow, then you're going to get someplace. But if you think that standards are confining, that is, you found the one best way and everybody should follow that one best way without thinking, without questioning, then he says progress is going to stop. This was quite profound. Is from his book Today and Tomorrow in 1926, which he obviously wrote earlier than that. So this is what Henry Ford believed. It's also interesting that over time, Henry Ford, the Ford Motor Company that Henry Ford was running, began to treat standards in the way that Henry Ford said not to, that is, as the one best way and confining. And at that time, we had Taylorism and we had traditional industrial engineering, which viewed the standard as defined by the expert and then followed by the people doing the work and then enforced by the supervisor. So the roles and responsibilities were very clear. The industrial engineers think, they're the scientific thinkers who understand the science behind creating the standard. The workers do mindlessly, and the supervisors supervise with tough authority. You deviate from the standard and you're in trouble. Now at that time, he was dealing primarily with manual work like shoveling iron ore, and he was dealing with people who didn't have, who came from other countries and didn't speak the language and weren't very well educated, and it was his vision that educated engineers would be the thinkers, the only thinkers in the workplace. And maybe there's some truth to it, or more truth to it than there is today. Also, the processes were fairly stable. There wasn't a lot of competition. In a stable environment, you can maintain the same standard for longer periods of time, whereas in a dynamic environment, you should be changing the standards as conditions change. There's actually a need to change the standard more often. If we put Henry Ford's idea into a diagram, into the process for long-term continuous improvement, we can think of it as stair steps, where the standard we can view as today's baseline, not necessarily the one best way, but rather it's the way that we're doing it now, and it's the baseline. And then when we see that there's deviations from the standard, we then ask the question, is this a positive deviation or a negative deviation? By positive I mean, is this a better way or is it a worse way that we have to correct? And when we find better ways, and particularly if we encourage the people doing the work and the supervisors to think, then we should be able to find better ways through time, through experience, and also adjust the standard as conditions changed. One of the things we know from Lean is that the best people to make these changes are the people who are closest to the process, the people at the Gemba, because they can smell, see, listen to the equipment, for example, as it's running every day. They know it better than anybody else. Now, when we do find a better way, then what we want to do is to test it, verify it, and then change the standard. So what we're doing is PDCA, 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 and as we do PDCA, as we learn, we adjust the standard. Why would we want to adjust the standard? And the main reason is because more than one person will be doing that job. More than one person will be doing something to that piece of equipment. And if one person has an idea and they understand it as a better way, then they can follow their own better way. But as soon as someone else tries to do the job, they'll do it in their best way. And then we won't have a common best way that we share, and then we also will not share any improvements. And therefore I will have my better way, and you'll have your better way, and we're not learning as an organization. In some organizations, I was in a company in Germany that is in the process industry, and they're running around the clock. And 24/7, they have 4 different people who are responsible for the same part of a machine. So they have to all come together and agree on the best way, for example, how to do a changeover or how to maintain the equipment. And they have a process for doing that. So Henry Ford gave us the basis for organizational learning. We standardize the best we know. We try to find better ways. We then re-standardize. We try to find better ways. We re-standardize. And standardization means a team of people sharing their best knowledge about the way we know today. And then we can use that stable new way as the platform for experimenting, for learning as a group, not just as individuals.
Jeff, on that topic of standardized work, have you found any valid reasons that people would have not to share the way somebody else does it versus have you come across that at all?
Well, it's valid in the sense that the reason that people I know in a lot of Ford plants and a lot of the plants in Michigan, auto plants in Michigan, the reason they did not share their better way was because once the industrial engineer got a hold of it, they would increase the performance standard, and people would have to work harder.
No, that's crazy.
So,
that's crazy, right?
So in that case, that was because they were smart. That was the reason for hiding the better way, was they were smart. But from the point of view of the organizational learning, there's no reason to kind of stick your idea in your pocket and hide it, and then on some certain date we'll all show ours. You know, there's not a game that I can think of in which everybody wins because we've been hiding our knacks or our better ways. So the result is that the company loses, and if the people in fact are given security by the company, if they're a part of the company, if they're a team, then the team wins or the team loses. If the culture is everyone for themselves, then it's better to hide your better ways, which is what has typically happened in traditional organizations. When I was working with David Meyer on the Total Way Field book, he developed this diagram, and I found it very useful because it put in perspective all the kinds of standards. We often emphasize in Lean standardized work, which is the sequence that you do the job, how long each step takes, as well as standard work in process inventory. That's kind of the conventional way of defining it in Toyota, and that gets a lot of play. And one of the reasons for that is because the auto industry is very manual, especially or mainly in assembly. We don't see behind the scenes the paint department or the welding department where there are a lot of robots and a lot of automation. And in those cases, people are doing a lot of monitoring, not as much actual manual work. But the bulk of the people are on the assembly line, and in that case, standard work for doing the job is critical, and taking out seconds when you're in high volume becomes critical, and that becomes a major focus. But if we look at these pillars, what we have are standard specifications that often do come from outside the work group. They can come in the foundation. We can see quality, safety, environmental standards, and these may come from the government. They may come from corporate departments who truly are experts on environmental issues, on safety issues, and also from engineers who are expert on the characteristics of materials or expert on what happens in chemical reactions. And in those cases, we don't want the worker to tamper with the chemical mixture that makes a drug, because they aren't expert at that, and they're likely to ruin the drug, maybe kill somebody or harm somebody. So there are, in fact, standards which are fixed that come from the outside, and we take as a given. When I've done work in process industries, particularly medical, they will often say, we can't simply put standard work instructions out on the floor and leave it up to the operators because we're a highly regulated business. And what they're really saying is we have many standard specifications that we have to enforce, and we can't leave up to the vote of the workers. And that's certainly true. There's no question about that. What is more flexible is exactly how I do the work. Like, I know this machine has to be maintained, and I have ideas about what has to be done to the machine. Filters have to be changed. Hoses have to be cleaned. I know those things have to happen. Tools have to be sharpened. I also have specifications that come from the vendor. Now, in the case of vendor specifications for maintenance, they tend to be a bit less scientifically precise than, say, the chemical mixture for a drug. And in fact, as you understand the machine, and also as the machine wears and changes, the operators and the maintenance people who know that machine can come up with new kinds of maintenance that should be done that maybe the vendor didn't think of, or the frequency of maintenance may change. So there's opportunities to change those specifications. And then how we do the work of loading and unloading, and how we do the work of changing over the machine, those can be significantly improved by the work group. And there's nothing completely scientific and deterministic about how you change over a machine and what steps you use and how you bring the tools to the machine. So there's a lot of flexibility for improvement. We also have to recognize that there are some standard procedures, there are some standard specifications which, in fact, the experts have defined and they know better than we do. When I was interviewing Nate Ferruta, who had been the first human resource vice president at NUMMI and then at Toyota Georgetown, and he's sort of a legend within the people who've worked in those Toyota plants. He's now running Toyota Boshoku. He just kind of looked across the table at me when we were talking about standards and said, without standards, there are no problems, only opinions. And he said that the first day he joined Toyota, he learned about the standards and he was asked to make improvements. When he made improvements, he had to make improvements in relation to the standard. This is the standard way that we do this job. This is the standard way that the workplace is laid out today. If I have an improvement, I have to prove that it's better than this standard way. I can't simply say, oh, I have an idea, I think it's a good idea. I think it's going to save some steps. I have to demonstrate that and then prove it's better than the standard today. So I have to know the standard today. And then if I can prove it in a convincing way, then the standard should change. So everybody knows the better way. So what he's saying is that in an environment where there are no standards, then it becomes more like free-for-all, democracy, anarchy, whatever you want to call it. But it's everybody's idea is equally good, because I believe that my idea is good. I can't prove it is or is not. When I have a standard and I've defined it, then I can objectively get evidence to show that my way is better, or the evidence might show it's worse. Oh, and one other thing is that one other thing that Nate Ferruta said that I thought at the time it seemed very profound to me is that the definition of a problem is a gap between the actual and the standard. So that is a really scientific definition of a problem. A problem means this is what I expect to happen, and this is what actually happens. And when there's a gap, then there's a problem. A problem means there's something I should be investigating. That's all it means. It doesn't mean that somebody messed up. It doesn't mean that there's a big defect getting through the customer. It doesn't mean it's an unsafe situation. It means that there's a gap between what I expect should be happening and what is happening. And when I investigate that gap, then that's how I learn in a scientific way. There's also standards which are aspirational. That is, I'm currently operating at this level of output per worker, and I'd like to operate at a higher level of output per worker. So my current standard for productivity is lower than the new standard I want to set. So if we talk about a goal or target, that can be viewed as a standard, and therefore we can create a problem. We could be operating perfectly fine to the standard level of productivity today, but when we raise the bar, now we're out of standard. So again, a gap is the definition of a problem, and the gap can be a gap to today's standard, or it can be a gap to what we aspire to, a new standard that we aspire to.
Well, I'm glad you explained that. I had somebody email me and say, I look at this visual and it doesn't make sense. I like it, but it doesn't make sense. And I said, yeah, if you just associate a problem is really a gap to the standard, it'll make sense.
Okay, good point. Yeah, that's critical, because I don't think we think of problems in that way. And in the last webinar I talked about how we often associate problems with something is wrong, and we have to react to that something wrong, and then that leads to firefighting. Now, I'll talk in a little while about Mike Rother's work, which I've talked about already, but he specifically chose the word improvement instead of problem solving because there's a association, a built-in psychological association for most people between the word problem and the word somebody's in trouble. And we're not thinking of the problem as a gap between where we want to be and where we are. We do think of a goal as being where we want to get to, and we can see ourselves striving to improve to reach that goal. And I think, again, that distinction between reacting to problems, to deviations, and striving towards something is an important distinction. And I'll get into that in a minute. Let's talk about then the relationship between standards and visual management. And as Nate Ferruta said, without a standard, you can't define a problem. And similarly, without a standard, you can't have visual management. Visual management, I would argue, is impossible without standards. What, in fact, visual management is doing is showing you a gap between the standard and the actual. So if you look to my left, when I'm looking at the screen, somebody's looking at information on a board, and it's just information, and it's interesting, and there might be even something useful, for example, a job posting. But that person is not looking to necessarily take action right now. They're not looking to see how am I doing compared to how I should be doing. They're just perusing the board, and it's sort of interesting. On the right, we have visual indicators which we can take action on, and a stoplight is one example. According to the law, which provides a standard, when you see a red light, there's a certain place on the road where you're supposed to stop your car, and if you don't, you're violating the standard, and that can be enforced if there's police around, and there can be consequences for not following the standard. So that's a case where the standard has become so ubiquitous that we normally would not even think about it as a standard. We just drive the car and we know when we see red we stop, when we see green we go. So that's not only interesting because it's a ubiquitous standard, but it's also interesting because it's become a global standard. You can go, as far as I know, any place in the world, and when you see a red light, you're supposed to stop your car. And that's, I think, the reason why we often see in various kinds of charts, red, yellow, and green being used as indicators. And normally people would not say red is good, it means go, keep going, and green is bad, because we've developed a mental standard of red being stop. We use that in this diagram for a meter. We could have simply had a meter that showed information about the pressure or the temperature. But as soon as we put red zones and yellow zones on there, we can see, are we in standard? Are we trending toward being out of standard? Once we're in red, we have to act immediately, or we could hurt somebody, or this batch might be a bad batch of material. So visual management, again, is really only a way of displaying the standard compared to the actual. And Kanban, it's often thought that Kanban is a tool for inventory reduction. It's a key tool in just-in-time, which is true in a sense, but really what Kanban was originally intended for is a type of visual control. Literally, when you translate Kanban, you translate it as a sign post. So I was walking with a Japanese student in Japan, and we were by the university, and there were some students protesting, and they had protest signs, and he points and he says, "Oh look, Kanban." You know, I'm looking for a Kanban card on a container, and he was talking about the protest signs that were Kanban. So Kanban is really just a sign that's giving information. And in the case of Toyota and just-in-time, Taiichi Ono noted that when we have one-piece flow in a cell, then we don't have work-in-process inventory, perhaps, in which case the signal, the sign that I should make the next part is that my partner next to me has just used the part that I already made. And that provides the visual signal, and it's very clear. But when we separate processes by some distance or time, then it's not so clear. We need to create some visual way of knowing my customer, my direct customer, is ready for more, and how much are they ready for. So this is an example of Kanban squares. If you're close enough to the inventory buffer, in this case the finished goods inventory buffer for this line, then you can see the squares on the floor, and when I put 3 boxes down, then I've filled all the squares, and then like a traffic signal I should stop. Now we see a problem because there's a 4th box, one that's outside of the 3 squares. There was no Kanban to tell me to make that box, and these people are still producing. So there's an out of standard condition. So again, visual management is very central to many aspects of the Toyota production system, and the reason that we use something like a Kamishibai board, which is showing bars for each worker or each process that says, here's how long this takes, here's how long this takes, here's how long this takes, here's the tact. So the Kamishibai chart, you're showing the heights of different people's workload compared to the standard, which is the tact. And in that case, if you're too high, then you're not going to be able to keep up with the tact. So therefore, you'd be underproducing. And if you're too low, you have waste, you have extra time. And if you use that time to make extra parts, you're going to be overproducing. A lot of the efforts of the Toyota production system are to make what otherwise is not visible, visible. And normally we want it to be visible beyond a computer screen, unless what you do is computer work. But in most cases, when we're talking about a process like in a hospital or in a factory that's not computer work, we want the people doing the work and the supervisors and the management to be able to see clearly, are we in standard, are we not? And we generally find it easier when we take it out of the computer, or the computer is running something like an andon that is big and it's very clear. You're red, you're yellow, you're green. Okay, that is for the benefit of people. The robots don't care. But the people, us, we are visual. So it helps very much if we can very clearly at a glance see, are we in standard? And then you could add to that chart work elements, individual work elements for each of those bars. And guess what? You make them green, yellow, red. If they're red, then it's waste. If it's green, then it's value-added work. If it's yellow, it might be necessary waste. So the same sort of visual, three visual levels.
There.
Excuse me?
Good way to see the opportunity.
Yeah, and the reason you're doing that is to make the opportunity visible to the whole team in a very clear and unambiguous way. And I tell a story in the Toyota Way to Lean Leadership that Gary Convis shared with me about being in a Toyota plant where a young engineer had all of that on a computer, and he could enter a new task or change the time, and that work balance chart would change automatically. And he thought that was really cool, and he thought that was superior to the physical models where they were using magnets and they're big and they're showing these bars relative to the tact. And then Gary asked them to do an experiment and try running it both ways with a group of people, and the conclusion of the engineer was it was a whole lot better when he had those big physical bars that people could see and they could move magnets around from one place to another. Okay, so now we know that we need a standard in order to define what we aspire to, what the desired condition is, and then visual management helps us to see that we have a gap between the actual and the standard, and we often make that gap red so it stands out. And now we can visualize the problems, and the question I ask is visualizing the gap enough? What do you do when you have done a really good job of creating a visual workplace, and when you look around, every place you can see red and you can see out of standard conditions? What do you do about that? And one view is...
Sorry, Jeff, if you can go back for one click. I know people are going to ask about the yellow. I have the answer because I took your course. But please go ahead.
Well, yellow can mean different things. At the simplest level, it means I'm somewhere between red and green. So green means everything's hunky-dory. I'm well within standard. Red means I'm in a bad state. It's hot. I've got to react immediately. Yellow generally means I'm trending toward being in trouble. So when we, for example, get Kanban cards back from our customer, if we're going to be batch producing, each Kanban might represent a container of parts, but we may not want to make only one container because of something like a changeover time. We might want to make several containers and make up a batch. So the cards are coming back, and the first, say, 3 cards are in the green zone, and that's not enough for a batch. I'm going to run when I get to the fourth card. When I get the fourth card, that will be in the yellow zone. I'll have an area labeled yellow, and when I put that card in a slot, it's now in the yellow zone, which means now I have enough cards that I can run a batch of 4 bins. But I'm not desperate. I don't have to run that right now. When it gets to the red zone, it means I'm in danger of starving the next process, and I better run that right now. It's now urgent. So green means I'm okay, red means I'm in trouble, yellow means I'm trending in the wrong direction. In other cases, people have used yellow to say, I've got a problem, but I have a solution that I haven't implemented yet, and therefore I have this under control, but I'll turn it green once the solution is in place and proven. So those are at least 2 different ways you can use yellow. Okay, so now what we're seeing are abnormalities, and now standard work becomes our theory about the best way we know today to do the job. I say theory because in the Kaizen philosophy, there's always a better way. So we can assume that there's a better way, that this is not the best way. And then when we see divergences from the standard work, these could be problems in the sense, well, they're always problems. The problem is there's a gap. But you can also view it as an opportunity for Kaizen, and it may well be the case that the different way of doing the job is better than the standard. So what we need to do is investigate to see if in fact this is a better way or in fact this is a worse way, and we need to then either enforce the standard or not enforce the standard. Let me respond both to the 2 questions and discussions that the panelists had. One discussion was about suggestion systems, and the gentleman was saying that they have a suggestion system. There's been a lot of suggestions. The suggestions are responded to within 1 day. There are pictures of before and after. So that's what I would call reacting to anomalies, or reacting to perceived gaps. I perceive a gap between where we are and where we should be, or where we are and where we can be, and then I make a suggestion. Move this container of parts from the bottom shelf to the top shelf because I use it more frequently, and that will then result in less wasted motion, so I'm eliminating waste. And you can take a picture of that before and after. The suggestion system is certainly something that Toyota has incorporated. There are more or less effective ways of organizing suggestion systems. If you stick a box on the way out the door for the workers, and you have an environment where the workers are not encouraged to think, and then the only suggestions you're likely to be is when somebody's mad about something. On the other hand, if you encourage the workers in their area and the team leader or the group leader is asking for suggestions, and maybe you have a board where you post them and there's kind of celebrations at all the great suggestions we've had, and people see that they're in fact implemented within a short period of time. I make a suggestion today, it's implemented tomorrow, we're trying it. Then that will encourage engagement of employees, which is a very positive thing. So suggestion systems are very positive. One of the benefits, one of the major benefits of suggestion systems, if they're managed correctly in the right culture, is that they encourage people to think and to be engaged. So I'm going to go beyond that in a minute, but just reacting to what we perceive as gaps with ideas, which then get tested immediately, is certainly one good practice. The question of exactly how you set a standard is, there's millions and millions of different situations, but the specific question asked is what happens when I have, say, a chemical mix or a process settings for my machines, and I'm running a different mix of products or even a different product on different shifts. So the settings for one shift should be different from the settings for the other. And if you think in terms of cooking, it may be, for example, that different recipes will take different heat levels. One takes 300 degrees, one takes 400 degrees. Now, we could say we only want one standard, and then we have to decide, do we make it 300 and undercook something, or do we make it 400 and burn something? And neither of those would be good situations. Or we could put it in the middle, take the average, and then nothing that you cook comes out well. So obviously we don't want to do that, so you need to have multiple standards. Even in terms of standard work, if you look at a Toyota plant, it may appear as though the worker is doing one job, but in reality they are installing different things on different cars. We ordered cars with different options, and if I'm going to have 8 speakers in the car, it's going to be different standard work than if I'm going to have 4 speakers in the car. So in fact there are differences in the standard work for an operator depending on what option is being selected, and that's on this sheet that's on the hood of the car that's showing them what option to put on. And if we have some complicated situations, for example, we worked with a company that makes various kinds of complex equipment that take many steps, and depending on the equipment there's completely different work instructions. So they have notebooks that would apply to different models, and you could color code the notebooks, or you could do various things to make it a little easier to identify what standard work I should be using for this machine. So certainly you need to have multiple standards when you have multiple conditions.
And wouldn't you also need a different standard for a different number of people in a workstation?
Yeah, and obviously, yeah. So you have a cell, and one of the beauties of the original cells that Taiichi Ohno developed is that he was striving for equal productivity at any volume level. So if I have twice as much demand, then I'm going to have twice as many people in the cell. If there's twice as many people, each person will be doing fewer steps, and they'll have less time to do their work. And then you pull out the standard work for 4-people cell. You pull out the standard work for a 2-person cell. If you can pre-make the standard work for different levels of tact, then you can just pull it out and change it when the demand changes. This is...
That answered my question. Thank you very much.
You're welcome. So this is then showing what happens when you are responding to problems as they occur, and this in fact is something that I have presented many times in my seminars as a kind of best practice. That is, what you want to do is to have standards of various kinds, and some of those standards are something like how we do the work, like standard work, and some of those are targets for what we'd like the process to achieve or how we'd like the process to run. And then we visualize the standards. That allows then problems to surface because we can see the gaps. Then we solve them one by one instead of waiting for the problems to accumulate in a big batch, which then it requires the experts like the black belts to come in and solve. When we have improved the process enough that we're comfortably operating at this level, then we will raise the standard to the next level, and now we will create a whole new set of problems. Or in the case of inventory, in a Kanban system, one of the nice things about a Kanban system is you take out a Kanban card, and now you have one less bin of material traveling through the system. And now you have, when I'm making parts or when using parts, I'm going to run out of parts more quickly if the supplier operation breaks down or takes too long to change over. So they have less time by having less material in inventory. They have less time to serve me as a customer, so problems will surface more quickly. So that, in fact, was part of the rationale for having a visual management system like Kanban, is we want to make visible exactly how much inventory is allowed in the system so that we can easily then reduce that inventory. You erase a square on the floor, or you throw out a card, and now we've raised the bar, we've increased the standard, and more problems will surface. And when we get comfortable at that level of inventory, we'll raise the bar again, so more problems will surface. So that sounds like a good idea, and with action lists, we also know you want accountability. What will somebody do, and who's going to do it, and when is it going to get done? And that's how you get this cycle of within 24 hours the suggestion is reviewed, and if it's got merit, it's implemented, or you get a response back if it doesn't have merit. There is a risk with action lists, which is what at various points we've called the fundamental trap of problem solving, and that is jumping from problem to solution without clear understanding and analysis. And one of the reasons we spend so much time talking about problem solving is because people have a natural tendency to assume that their idea is the new best way. It just seems to be a built-in human bias. And what we do with PDCA, with practical problem solving, with 8D, whatever problem solving method you want to use, what we're doing with that method is we're stepping back and saying, wait a second, do we really know this is an improvement? And if so, how do we know? Let's look at the evidence. Do we even know that this is a problem? Somebody thinks it is, but do we know it is? Do we have any evidence that it is? So what we're trying to do with problem solving is to slow people down and actually get them to understand what it is they're trying to accomplish, the purpose, where they're at now, the current situation, and then test their ideas one by one to see if in fact they do have a better way. As soon as I put up a big action register that says what, who, and when, and it's a free-for-all, anybody who has an idea, write down your problem that you notice, or every time there's an and-on pull, I write down a problem, or every hour on an hour-by-hour chart, I write down we're behind for this reason, therefore we have this list of problems. Then what I tend to want to do is to go through that problem list as fast as possible, react to every problem with either I'm changing the standard or I'm not. And that risks making a lot of mistakes, doing a poor job.
To avoiding the jumping to conclusions, any countermeasures you have
Yes.
other than breathe?
And it's on the next few slides. That's what I'll talk about. So what is the countermeasure? How do you get people to be more disciplined and to slow down? And one is the perspective we have on being out of standard and how it relates to Kaizen. So in this case, we're showing that the standard's in green, and in the early observation period, we have deviations from the standard. Again, this could be any kind of, there's many standards. So let's say it was a safety standard, people aren't wearing their protective equipment. Or let's say it's a setting for the temperature of the equipment and it's going all over the place. Now you can see that even in the early stage, all these deviations are within the upper and lower control limit. So in fact, we're really not out of standard. We just have variation from the mean. So in this case, we're okay, and we wouldn't necessarily want to react. But what often happens is that we do react. I was in a company in Finland last month, and the manager in charge of continuous improvement was concerned because they had set up daily huddles, and what they were looking at is today's condition compared to yesterday's condition on a bunch of key performance indicators. And if they got worse, then they would go into a problem-solving mode, or at least they would come up with suggestions for improvement. And her concern was that these could just be random deviations that are still within a process in control. So one of the things we learned from Dr. Deming is that when you take, let's say, you shoot at a target, if you miss the target, the question is, what do you do? And the answer is, shoot again. So you can see what the pattern is. And it may well be that you're in control, or it may well be that you're in control but the mean is shifted, so you just need to shift the gun. But there's very little variation between your shots, which is a good thing. So simply reacting to deviations can be a little bit dangerous. Now then what we show is that they have increased the standards. They've reduced the range of acceptable variation. There's a new upper and lower control limit. And then they had to make improvements in the process in order to reach this new level of variation that's acceptable. So when we see a deviation from the standard, it really says there is variation. That's all it says. It doesn't tell us whether the variation is good or bad or acceptable or unacceptable until we've defined control limits. Once we've defined control limits, we now have a target, a new target that we're striving for. We're striving for a smaller amount of variation. And then we have another situation, a second situation, and this was the case in the warranty example I talked about in the problem-solving chapter, which in this case there was clearly a new standard desired. It wasn't simply a matter of reducing variation. The goal was to reduce warranty costs in North America by 60%. So this is a huge shift in the mean. And you can see that there's variation, but you can see that the general trend over the first 4 years was on target with the mean shift. And they'd gotten to the point where they had achieved a 40% reduction in 4 years. Okay, so we can either be reducing variation, or we could be trying to increase or decrease the average. In both cases, we're striving for a new level of performance. Performance that's more consistent with less variation, or performance at a new level, at a new mean level. And there's really no difference between those. The implication of that, and again, I got this insight mainly by talking to Mike Rother, and I in fact resisted it pretty violently because I had learned from Toyota that there's two kinds of Kaizen, and we wrote about it in Toyota Culture. One is maintenance Kaizen. We're simply trying to maintain the current standard and make sure we consistently hit that current standard. And that's a certain type of Kaizen, and that's what you do through the daily management system of seeing and reacting to problems as they occur, through suggestion systems, for example. Then there's another kind of Kaizen in which we're trying to improve to a new level of performance, which in Toyota they say that's true Kaizen. True Kaizen is improving to a new level of performance, a new mean level. And what Mike was saying is, I don't think those are different. And I couldn't understand why he would say that, because they seem so different to me. But then what I realized is that what maintenance Kaizen is really saying is we want to reduce variation. We've got a rule, we've got a standard for equipment, and we want that standard ideally to be the same every time. 4 people do the job, they're doing it in the same way, they're getting the same results. Every time they do the job, every cycle. If you actually measure even one person through cycles, you will always find variation. So therefore, they're out of standard. Maybe every single time they're out of standard. Not necessarily within the range of standard, but they're not hitting the mean. So in that case, what you're trying to do is to reduce the variation, and that becomes your target. And then I would ask, how much do you want to reduce the variation to? What are your new control limits if you don't like the control limits you currently have? And that becomes a new target. that's really no different than a target that says I want to have the average be 40% better. I want the variation to be 40% less, or I want the average to be 40% better. In some sense, those could be equally challenging targets. So now we have a target, and that we have some reason to believe we want to do something about. And what, again, Mike added to the discussion was the idea that when we are striving toward a target that's clear, we behave differently than if we are eliminating every waste we can see or reacting to every deviation from the standard that we see. When we have a target, there's some direction, and there are certain things that we have to do to improve, and there's other things that we can do to improve something. We see something out of place, something is messy, we see that there's some extra steps being taken by a worker someplace, and these are in the 7 wastes, and we can say we have to eliminate that, we have to eliminate that, we have to eliminate that. Those may be all eliminated but not bring us any closer to our target because they're not related to the target we've set, say to reduce variation in this equipment, because unless we do that, we're going to have a product that is out of standard and is dangerous to our customers. That's what we're currently working on. And we're going to ignore the things that don't influence the adjustment of the machine to make a good product. And then within this corridor of problems that are relevant, that's where we will focus our attention. So now we have a focus to improvement. And then he provided a method for doing that, and the method could be A3, it could be many kinds of problem-solving methods, but what Mike was saying is that what we need is some method which includes as a basic component that we break down the big target, say the 40 or 60%, into smaller targets that are closer to us. It's hard to think about 6 years out and 60%, but it might be easier to think about the next thing we can improve in the next 2 weeks. And we want to improve in the next 2 weeks toward a target condition. So in order to reduce warranty, one of the things we have to be able to do is we have to be able to hear noise and vibration in this process. And currently we can't hear the noise and vibration well enough, we discover. And our next target condition is to find a way to make it easier for the inspector to hear any noise and vibration. And we believe that that's a reasonable target condition for the next 2 weeks. And that's what we're going to work on. And then when we achieve that, then we're going to ask what is a logical next problem to work on within this green corridor, within this corridor of problems to solve that in fact will get us closer to the target of reduced warranty. So this is a very different way of thinking, and it's a very different improvement process. Now when we use something like an A3, what often happens is that we are doing it under the supervision of, say, a black belt, and we've been asked to do this project. Maybe it's part of a training course, maybe a consultant has been hired, and then we do the A3 and we follow all the steps and we do a really good job of it, but then that person goes away and we don't do it again. So what Mike was saying is we really need for plan, do, check, act for this scientific way of thinking to become our habit, our new habit. Our old habit is every time we see a problem we react and we write it on the action register and we're done. The new way is when we see a problem we ask, is this something I should be spending my time on? Is it, and we have to set some rules. If it's a safety issue, yes, you need to pay attention to it right now. If it's potentially a quality issue that will influence the customer, yes, you need to pay attention to it right now. So there may be some ground rules like that. But other than something that has that urgency, the standard response might be, let's record that someplace or make a note of it, but that's not relevant to what we're trying to achieve, what our current challenge is, what our next target condition is. So we might intentionally ignore some problems. And now we have a focused search, and then if we get into this habit of thinking about the target, and then I have to understand the current condition right now, and then I need to identify some obstacles and pick a possible countermeasure that will overcome the obstacle, and then I have to test it and see, does this in fact improve closer to the target or not? When I have that kind of thinking, that kind of scientific thinking, I'm going to be much more likely to achieve the big challenges and also be much more efficient in how I use my time for improvement. Now, if I think about this as this is a good improvement process, this is what we want. We want improvement to be scientific, systematic, focused on targets. And I think that's kind of the college level or the high school graduate level, that's the educated level of improvement. I would think of the suggestion system as more like the freshman level or even the elementary school level, which is let's let these people just come up with ideas randomly and we'll implement them as fast as possible because we want to encourage them and make them feel good so they'll make more suggestions. That may be useful at some stage of evolution of the maturity of the plant to simply encourage any ideas. But it's not following any kind of scientific problem-solving method. And in fact, as people do that and they see their ideas are being implemented quickly, then it reinforces, in some ways, the wrong way of thinking, the wrong behavior, which is any idea I come up with has got to be a good idea and somebody should take it seriously. So the way another contribution that Mike made that he in fact thinks is one of his most important contributions is recognizing that there are some cases where we in fact know what the problem is and we know what the solution is and we're in the predictable zone. So for example, the machine shuts off, the printer shuts off. I look around, I see that somebody tripped over the plug and it came out of the wall. And I plug it in and the computer or the printer starts again. I don't need to do a lot of PDCA to stick the plug back in the wall. In that case, I'm in the predictable zone. The problem is clearly identifiable, the solution is clearly identifiable. I solve the problem and I see that everything's fine now. Everything's great. When I'm in this predictable zone, I can jump from problem to solution. And there may be cases where I know my equipment well enough that I can immediately see there's a problem, I can hear there's a problem, and I know it's because the tool is wearing, and I know that I have to change the tool or sharpen the tool. And I then realize that this has happened 3 times this week, so I have to change the tool or sharpen the tool earlier than I expected. And maybe I just want to do that. So there are just do-its in the world. Then what Mike said is, we have a current threshold of knowledge. There are things we know, but there is a lot more that we don't know. And for what we don't know, that's where we want to use this systematic improvement process. That's when we want to take, say, deviations from the standard and say, should I pay attention to those or not? What is my target condition, my next target condition toward the challenge? And then I'm using this improvement process, what he calls the improvement kata, in order to try to learn my way through experiments through this unclear territory. And that's when it's useful to be systematic. It's useful to measure and observe the current situation. It's useful to test alternative ideas. It's useful to check to see what happened when I tried this idea. We're running experiments. We're like scientists. Scientists don't do scientific studies to study known knowledge, known information. They are hypothesizing something that is not currently known. So in our facility, in our operation, in our hospital, and in our workplace, when we are trying to reach a goal and we don't know how to get there, that's when we want to use a systematic process like the improvement kata and run experiments. Now, the problem is that we too often think that we're in the predictable zone when in reality we're in the unpredictable learning zone. And those of you who've read Daniel Kahneman's book about fast thinking and slow thinking, he will know that he lists hundreds of biases that have been proven in cognitive science experiments that lead us in the direction of thinking we know what we really don't know, of making assumptions. So again, when we have as our main improvement method hour-by-hour boards or visual management deviation from standards, and people who are making suggestions, immediately writing down the problem and the solution, we're encouraging people to think that they know almost everything. Most of the problems that need to be solved are all in the predictable zone. And many of those are in the unpredictable zone. And then there's also within the unpredictable zone, there are problems which will, if they're solved, will lead us toward our target, and there's problems that are pretty irrelevant to our target. So we have an unfocused process of randomly throwing out ideas and implementing them. So what points have I tried to make? First of all, there are many types of standards, and some of those come from outside a work group, and some of those are created inside the work group. Some of those should be in the control of the work group when they don't involve a clearly known way of doing things scientifically that's beyond the knowledge of the group, such as a technical standard for the product or a safety standard. Standards are the way we define problems or gaps. A problem is actually a gap between where we want to be and where we are. And that gap can be that we have variation. We would like to have this level of performance with very little variation in the way people behave, because it's unsafe to behave outside of this boundary. And people are outside the boundary too often. So that's a problem. We want to reduce the variation and bring people back to the standard. It could be that we have a new level of performance we're trying to achieve, so we're shifting the mean. In both cases, we often think we can solve those problems, those deviations from the standard, with quick action lists. And most often, we're in an unpredictable zone. What we think we know may not be so, and therefore we should be striving to achieve the new standard through a deliberate process of improvement. So that summarizes the points I wanted to make, and I'm open for questions.
Quick question, Jeff, please. Thanks. How often should you critique a standard? Should it be hourly, daily,
I don't think there's any rule.
weekly?
I don't think there's any rule. The reality is that we're surrounded by standards in our workplace. And some of them we don't even know about. But there are environmental standards, and there are quality standards, and there are productivity standards, and there are cost standards, and there's standards for the physical location of things. And so we're surrounded by standards. And if we were to go around, again, challenging all these standards every day, that's all we would do. It'd be like a dog chasing his tail. So we have to be very deliberate about what standards we challenge. And again, if we believe Mike's assertion that number one, we have limited time for improvement, so that time should be spent on on standards that are relevant to a target, that are relevant to a business challenge. Then that gives you one answer. Focus on the standards that matter for what you're trying to achieve right now. And then if we also believe a second assertion, that people tend to assume things are in the predictable zone when they're actually in the uncertain zone, then the answer is, when we do challenge a standard because we think it's going to help us to achieve our goals, we should be systematic about it. We should be running experiments and checking the results of the experiments.
Hi Jeff, I have a question. Are there standard elements within a standard work
Yeah, well,
procedure?
when we talk about work procedure, it can mean different things. There are some work procedures that are inherently sequential, and that would be the case for, say, an assembly line job that's very routine. And then there are other kinds of standard procedures which are not necessarily sequential. So that might be the case for the repair of a complex piece of equipment. Each piece of equipment that you look at may have different problems. Now, at a high level, you might say the first thing you always do is inspect the equipment. But exactly what you inspect, how long it takes to do those steps, some part of it might be standard. You might have a standard. We worked with the Navy on nuclear submarines, and we're working in the ball valve area, and there are some the ball valve had a lot of variation. We were working on aircraft with fighter jets, and it was the same fighter jet. And whenever the fighter jet came in, there were certain things that you were required to inspect for every single one that came in, and there were certain parts that you automatically replaced. So that was the standard part of the job that you could specify down to the work element, the sequence, even timing. And then there was the unknown about what's wrong with this plane that I should be working on, and that required a lot of creative diagnosis, and it was difficult to anticipate how long that should take or what sequence you should use to identify different problems and solve those problems. So there'll be some standards which are checklists that say we need to make sure we check all these things, but the sequence is going to vary. There's cases where the sequence is clear. We also have, when we develop standard work and we say that we need to attach the bumper, we can then break that down into 5 different sub-steps of attaching the bumper. And for each of those sub-steps, we can have key points, and that's sometimes called a job breakdown sheet. That would break down this one step of attached bumper into 5 sub-steps, and with each one is a key point, and that's used for training purposes to train at the detailed level. And the standard work is used for looking at for developing those bar charts and for looking at balancing the work across people. So there's different levels of granularity depending on your purpose and depending on the task that you're looking at. And in some cases it's clearly sequential, in some cases it's not.
Okay, thank you.
Okay, I'm going to ask questions and read them off as I see them here. Okay, how do you define a better way of a specific assignment? Is, for example, quicker method always a better way of doing the task?
A quicker way, if, again, you have to put this in the context of the purpose, what you're trying to achieve. So let's just take as an example the cell, which is kind of the classic in lean. We have a cell, and we have, say, 4 people in the cell, and there's a takt. We want a product every 2 minutes. And currently, for one job that we've defined, it takes 1.5 minutes. Now I speed up that person, what am I going to do? All I'm going to really be doing is allowing that person to take a longer break or to overproduce more. So in that case, speeding that person up can actually be harmful. On the other hand, if you see some of the more advanced plants, they will have these work balance charts posted, big work balance charts posted, and they have the waste is red and the value added is green, and they're constantly trying to speed up. What they're really doing is not speeding up, they're reducing the time it takes to do a work element. When they reduce the time it takes to do a work element, it may be that somebody's underloaded now. But what they're going to do is, on a regular basis, they're going to look and say, can we move these work elements? And they're, in fact, going to move the work elements so that if they have 4 people, 3 people are loaded fully, and 1 person is the least loaded. If I can get that person down to, say, a half of a job, there may be some other job that they can do with the other half of the cycle. That's one possibility. They may be able to take measurements. If I want to measure something for improvement, they have a half a cycle each time to measure something. So there are various things that they can do. Maybe there's a broom right there and they can clean up. But more important than that, as I continue to take out time from work elements and I continue to take work elements away from that person, I can get to the point where I eliminate that position. I eliminate that process. And now I'm doing the job with 3 people instead of 4. So if I'm using those speed ups systematically, then I can get small changes that each don't make any real difference, but when they add up, I'm actually becoming more productive.
Here's another one. Could you address the issue of creating standards in a high mix, I'm thinking high mix, low mix environment. I think it's high mix, low volume. We struggle with how far to take this in our environment, but we are working on visual indicators versus our schedule. Perhaps the schedule is our standard.
Yeah, I don't know if the schedule is your standard or not, but when you're in the case of high mix, again, I think what you need to do is to think in terms of improving toward targets instead of what should we standardize. The question of what we should standardize cannot really be answered without understanding what it is you're trying to accomplish right now. And what it is you're trying to accomplish right now is presumably different than what you'll be trying to accomplish next year, because you're trying to raise the level of the process over time, and in addition, conditions will change. Maybe some of your some of your products will go away, or somebody will decide we should simplify our product line. Today, what are the problems that you want to work on, and that means that you have a plan for what you want to improve. So if, for example, on a particular machine that today is a bottleneck, you would like to be able to make a larger variety of products in smaller batches, because you have a vision, you have, say, a future state value stream map, and it's showing that you're trying to get product to the customer more quickly because that's a competitive advantage, or you want to reduce batch size because you're trying to reduce inventory and free up cash for the business, and that's a major focus. So you have some business reason for wanting this machine to make smaller batches as part of this overall vision you have for the value stream. So now I'm going to look at this machine and I'm going to ask, why can't I make smaller batches? And then one of the answers might be the change over time. So in that case, you're going to want to look at, you can follow the improvement kata, you can follow, which is really the kind of standard method for reducing change over time, which is understanding your target, understanding the current condition, and then starting to make changes and testing those changes to see if they reduce the the time to change over, and then when they work, you standardize those changes, and you train all the operators, and the operators can be involved in that. So now you have a clear focus. We're reducing the changeover time, and then when we reduce the changeover time to reach our target, the next thing we're going to do is lower the batch size and lower the minimum and maximum allowable limits of inventory. So that will be a different standard that will then change, and we'll start to move toward a pull system. So there may be various elements of the system that in fact are connected because it is a system, but we have a direction. We've broken down the direction into pieces. We're experimenting with those pieces, and we're developing new standards. And the schedule may in fact change as you shift from push to pull, as you have more capability to change over more often and reduce batch size as your lead times go down. That in fact will change the schedule. So I wouldn't view the schedule as the standard, because the schedule may be a schedule based on a low level of capability.
Okay, I'll open it up. A last chance to ask questions from the panelists. Go ahead, anybody.
Hi, Jeff.
Hi.
I want to ask you something. When we are developing a BSM, sometimes we try to set a WIP, working process, between operations, one operation to another. But if we are trying to reduce the inventory, how can we set how many pieces can we have between these operations?
There's a standard equation for calculating how much inventory you should have in a given buffer. And basically there's two components to it. One is the lead time to replenish the buffer. From the time I use a part, how long does it take to replace that part? And that includes the travel time, and includes the time for the machine to start making that part and then finish making that part. So let's say it takes 4 hours before this machine is going to make another part. Then when I use a part, I know that I'm going to have to wait up to 4 hours before that part is replaced. So I better have 4 hours of inventory. And that's if assuming everything goes perfectly, and exactly when I use the part, I'm going to start making it, which is usually not a good assumption. So that's the kind of deterministic part, is the lead time. And although there could be variation in lead time, but the other issue is that I need safety stock, because there's variation. There's variation in customer demand. There's variation in the production of the part. There's variation in the delivery of the part. And then the question becomes how big should that safety stock be? And there are ways to estimate how much the safety stock should be using statistics and standard deviations, and saying I want 99% confidence, and based on the current variation, therefore I need to hold an extra 4.5 hours. Or sometimes people will use a rule of thumb and say, I look at a chart and I see about 25% variation, which turns in, so therefore I should have 25% plus or minus extra on the high and low side. So normally what you'll see in a Toyota plant is that the buffers, they will look at the lead time, and then the safety stock will be set through judgment and then trial and error, like an experiment. And we will keep on adjusting the buffers based on experience. So either way, you need to have enough to cover the replenishment time, and then you need to have some safety stock to cover variation.
Jesus, I hope that answers your question. Jesus. Any other questions? Last question, and then thank you very much, Jeff, for the great day. But one more question, guys. Go ahead.
Jeff, thank you for taking a question. How do you make standard work work in concert when you're dealing with the ISO 9000 requirement?
Okay. Well, the ISO 9000 requirements, as I understand them, simply say, you tell me as an auditor what you're going to standardize, how you're going to standardize it, how you're going to control it, and then you stick to your plan. And when I come out, I'm going to check whether you're following your plan or not. And there is a question, for example, whether certain aspects of the process that don't influence customer quality, like, for example, the sequence in which somebody does a job, what's on a standard worksheet, whether that needs to be part of your standards that the auditors audit. And that's a question. Sometimes maybe the answer is yes, sometimes it's no, I don't know, but it's not always yes. And there's a question whether the sequence of steps and the way I do a changeover needs to be part of the ISO standards. In any case, as long as I have standard specifications that say that I'm going to lock out the machine, and that's a safety issue, and that I'm going to make sure that I test the first part's quality, those could be standards. But the specific way I do the changeover can vary. So what you might consider is you promise to the ISO auditors the least you can promise, which gives you some flexibility to then change what really will not influence safety, will not influence quality. The other answer is that there are many plants I know that find ways to satisfy the controlled document requirement, and they still change the standard work. It's not usually going to change every minute of every day. It's more likely it changes once a week if you're doing pretty well. And you can have as a standard that they can write in the standard until they prove the new standard, and then it will become a controlled document until there's another improvement. And with computers, you can make changes pretty quickly. So companies that think about this clearly and that work with the auditors, I found usually don't have a big problem. It depends on the auditor, but in more cases than not, if you're at an advanced stage of lean, the auditor is going to be blown away. They're going to be so impressed by how stable your processes are, how disciplined you are, how much you've standardized, that they're going to, and if you explain that we ask the operators and the work groups to make changes, and once a week we check and whether those changes should be added to the control documents, that sort of thing, they probably won't be too concerned about, because they're so impressed by everything you're doing to make sure that you're following all the standard specifications that need to be followed. You should.
Okay, everybody, you guys can take yourselves off mute. Say thank you to Jeff. Jeff, we'll see you next month in January, and we have Michael Ballet January 6th as well. So thank you, everybody. Thank you, Jeff.
Have a happy holiday, everybody.
Thanks, Jeff.
Thanks, Jeff. Thanks, George.
Thank you both.
You're welcome. Take care.
Thank you. It was very good.
Thank you.